Imagine standing outside on a crisp, completely clear night, looking up at a sky just totally packed with stars. For thousands of years, we've looked up into that endless dark and asked ourselves, what's actually out there? And more importantly for us today, could intelligent robots be the key to building our future out in that vast unknown?
It really brings up that ultimate generational question, doesn't it? Are we ever going to live on another world? Like, will people one day actually walk out of their front doors into a city built on the moon? Could the dream of a permanent human settlement on Mars seriously become a reality in our lifetimes? These ideas have inspired scientists and explorers for generations. But there's one massive, undeniable problem standing in our way.
Okay, let's dive into this. Part 1, the dangerous reality of space.
Because as beautiful as the cosmos looks from down here on Earth, the reality up there is, well, it's incredibly hostile. We are talking about insane temperature swings. Mars alone can drop to a bone-chilling minus 225 degrees Fahrenheit. Plus, there is intense, nonstop radiation. You've got communication delays that stretch for grueling minutes, which means a real-time conversation is literally impossible. And because of all that, doing even the most basic repairs is incredibly dangerous, making human missions brutally hard and astronomically expensive.
So, what's the solution? That brings us to part 2. Meet the digital explorers.
And this brilliantly illustrates our definitive advantage. What if we just changed our entire strategy and sent AI agents first? It's a massive paradigm shift. Think about it. Human astronauts need a constant supply of food, oxygen, and rest just to survive the trip, let alone do any actual work. But AI agents, they never need life support. They don't eat, they don't breathe, and they never ever get tired. They can work continuously, day and night, for years, prepping another world before we even leave the launch pad.
Which leads to part 3, preparing Mars and the Moon.
Just picture a future mission to Mars. The second a robotic spacecraft touches down on the dirt, thousands of specialized AI agents boot up and get to work like a highly coordinated construction crew. Step 1, they meticulously map out the landscape. Step 2, specialized agents hunt for subsurface water ice and analyze the soil. Then, step 3, they actually collect local Martian materials to manufacture physical building blocks right there on site. Finally, they construct protective shelters, set up massive solar arrays, and test out the life support. By the time a single human astronaut arrives, all the most dangerous prep work is completely finished. And hey, this exact same approach is going to revolutionize lunar exploration right in our own backyard. We're talking AI robots working around the clock to build permanent research stations on the moon. They could run autonomous mining operations to pull useful resources right out of the lunar dust. They could even construct giant radio telescopes on the far side of the moon, perfectly shielded from Earth's interference. The whole shebang, all supported by intelligent AI working 24/7.
Let's scale this up. Part 4, surviving deep space journeys.
Let's think even bigger, way beyond our moon, beyond Mars. Imagine a spacecraft traveling for decades toward a totally different star system. A human crew would face pretty much insurmountable challenges on a trip like that. But AI agents, they could flawlessly monitor complex ship systems around the clock, physically repair broken equipment, and manage long-term scientific experiments while the human crew is asleep. They can instantly adapt to unexpected emergencies, which makes highly ambitious, deep space exploration actually practical for us. So, the crucial point is part 5, the challenge of distance. The logistics of making all this work brings up a really critical question. Can an AI truly make decisions when it's millions of kilometers away from Earth? I mean, communicating with Mars already involves a delay of up to 22 minutes each way. A spacecraft exploring even further out might sit there waiting hours just to receive a single instruction from us. Because of that crazy delay, the AI can't just pause and wait for permission to fix a critical error. AI agents have to be able to make routine, day-to-day operational decisions completely on their own. But, and this is key, the balance of power is strictly defined. The AI operates autonomously, sure, but only within very carefully defined safety limits set by human mission control back home. Basically, humans set the goals, and the AI figures out how to execute them safely. And this is where reliability becomes absolutely crucial. The difference in repair environments here is stark. On Earth, if a machine breaks, you order a part, someone comes out, and it's fixed. In deep space, there is no hardware store. Replacement parts are literally never going to arrive. A single broken gear millions of miles away could instantly end a $1 trillion mission without backup systems.
That's exactly why engineers spend years planning for failures, demanding extreme robustness and intense backup redundancy from these AI systems before a mission is ever greenlit.
Let's move to our final point and see how this all builds together. Part 6, humanity's new space pioneers. Looking to the horizon, humanity's expansion into space is going to rely heavily on these brilliant digital minds. The very first builders of our first Martian city won't be humans, they'll be machines. History always remembers the human explorers who bravely crossed vast unknown oceans. But our next great explorers, they'll be crossing the solar system, and they'll work silently, patiently, intelligently. AI isn't here to replace astronauts, it's our ultimate partner, paving the way so we can follow safely. Because before we can truly dream of living among the stars, someone has to build the foundation. And perhaps those first pioneers won't breathe. They'll think.
What an incredible thought to end on. If you enjoyed this explainer and want to keep exploring the absolute bleeding edge of AI, space exploration, and human innovation, make sure you hit subscribe and turn on notifications right now. In our next explainer, we are going to ask, can AI agents accelerate scientific discovery and actually help solve humanity's greatest mysteries? From clean energy to new medicines. You definitely want to join us for that next adventure, because our greatest discoveries might just be waiting for us out among the stars. Catch you next time.